a look at something that we talked about in Algebra 1. We're going to simplify this expression. In order to simplify it, what do we need to do? Not go faster. We want to condense it down. Do what? Here. Put the like terms together. We're going to combine our like terms. So this is a 9x squared. Is there another x squared? Yeah. What do we get? We combine 9x squared and negative 3x squared. 6x squared. Okay. Here, this term has a y. Does another term have a y? 14. So what do we get when we combine 6y and 14y? 21. Does this 2 have a like term? No, so it doesn't change. It stays how it is and we just tack it on at the end. So this is an example of, we just said it, combining like terms. For us, this has always meant that we should add or subtract the coefficients. On each term with the same variable. So x or y, or x squared, y squared, x cubed, etc. This idea of combining like terms can be used with radicals too. We can use the same concept when combining radicals. So, let's take a look at some examples. Here, we're going to simplify these down by combining like terms. So if I look here, this one has a radical 5, and that term has a radical 5. So we can combine that. Just like when we combined with variables, only the numbers out in front, the coefficients will change. So we combine, we're just going to do negative 2 plus 5, which is what? 3. Radical 5. Very good. The radical does not change. It's just how it is. Then we can do the same thing here. We can combine, this one has a radical 3, and this one has a radical 3. We combine 6 radical 3 and negative radical 3. What do we get? 5 radical 3. You're going to think that's a 1. 6 minus 1 is 5. Tack on the radical 3. Are these two like terms? No, this one has a radical 5, that has a radical 3. They are not like terms. So that's our answer. Okay. Here, what do we have to do with that 2 out in front? Before we do anything, think order of operations. Distribute it. We have to distribute that 2 first. So we do that. 2 times radical 6. Very good. It's just 2 radical 6. This 2 times 1 is 2. Tack on that radical 6. Minus 2 times 4 is 8. Tack on that radical 11. Do we distribute the 2 to the other radical 11? No, because it's not on the inside. So we just rewrite that. We just bring it back down. Now do we have like terms we can combine? Yeah, we have these radical 11s. There's nothing to combine with the radical 6, so we just rewrite it as 2 radical 6. And then we combine our radical 11s. Negative 8 radical 11 and positive radical 11 is what? Negative 7 radical 11. We can't combine those because they're not like terms. Then we take a look at C. Are those like terms? No, so there's nothing we can do with it. So when that happens, you look at it, there's nothing you can do. check and see, can I simplify my radical? Is there a radical in there that we can simplify? Yeah, we can simplify radical 50. What's the largest perfect square that can go into 50? 25. How many times? 2. Square root of 25 is 5. Tack on the radical 2. Can we simplify 4 radical 2 at all? Nope. So we just drop down that negative 4 radical 2. Now do we have like terms? Yeah. They're both like terms. What do we get when we combine 5 radical 2 and negative 4 radical 2? 1 radical 2. You can write the 1. You don't have to write the 1. But radical 2 or 1 radical 2 is your answer. Questions over that? So to take away from this, we add or subtract the radicals that, when we do that, we treat it like a variable. This means we only add or subtract the coefficients on the radical. The radicals don't change, just the numbers out in front. Over that. Unlike addition and subtraction, when we multiply or divide radicals, we not only deal with the coefficients, but also their radicands, which is just the number underneath the radical. So add and subtract, you only change the coefficients on a radical. Multiplying and dividing, you change everything. You can multiply the coefficients, you can multiply the radicals. Okay, everything changes. So we take a look at some examples. When we multiply our radicals here, multiply the numbers out in front, the coefficients. So 6 times 2 is what? 12. Then multiply the numbers underneath. 10 times 3 is 30. So that becomes 12 radical 30. Can we simplify radical 30 any further? Oh, so we're done. There's no perfect square that can go into 30, so that's our answer. If we take a look at B, again, same thing. Multiply the outside numbers together. Negative 2 times 10 gives us what? Negative 20. Square root, multiply the numbers underneath. 8 times 5 is 40. Can we simplify radical 40? Yeah. There's a perfect square that can go into 40. What is the largest perfect square that can divide into 40? 4. How many times? 10. Don't forget, bring down that negative 20 out in front. So we get negative 20 times, what's the square root of 4? 2. And we take the square root of 10. No, it's not a perfect square. And then don't forget this last step. What's negative 20 times 2? Negative 40. This becomes negative 40 radical 10. That looks like a 6. Let's change it to a 6. Questions over that? If we take a look at C, okay, I know when you're looking at this, you might be thinking, oh, I can simplify radical 75. Do not simplify anything till the very end. Do everything that you can to your radicals, and then at the end, if you can simplify, simplify. Okay? Or like this example, there's nothing we can do. Okay, so if there's nothing you can do, then simplify and finish the problem. Okay? But here, we can do some stuff to see before we start simplifying. And it makes your life easier. If you simplify too early, it actually makes more work for you. So wait till the very end to simplify. So let's divide first. When you divide radicals, divide the numbers out in front. 12 divided by 4 is what? 3. So we're going to divide these two numbers together, 12 and 4, and it gives us 3. And then what you're going to do is divide the numbers underneath your radical. Okay, so you're going to do 75 divided by 5, and that gives us what? 15. Okay, so that becomes radical 15. Can we simplify radical 16 any further? No, so we're done. So much easier. If you simplify that 75 right off the bat, you're going to have to end up rationalizing your denominator, and it's going to be super messy. So just simplify at the end. After you divided everything, you can divide, add everything, you can add, multiply everything, you multiply, then simplify. Yes. So we will tell you. So like here, it's telling us to multiply, so we multiply. Here, there's plus signs, and addition signs, so we know to add. So it's just like numbers and variables, whatever it's telling you to do, you do. You just have to use, remember, order of operations and do it in that order. So you just can't pick when to add and subtract. You have to go 10. You have to follow those order of operations. Yes?
So for only multiplication, you can deal with like the number underneath.
Correct. And division. When you add or subtract, treat it like a variable. So when you combine like negative 2 radical 5 and 5 radical 5, it does not become 3 radical 10. It just stays exactly how it is, only the numbers out in front change. When you multiply radicals and divide, you multiply the numbers out in front, you multiply the numbers on the inside.
So
Nope. They can be different when you multiply and divide. They have to be the same when you add. Good question. Other questions? So, combining it all together. So now it's multiplying, dividing, and adding, and subtracting all in one. So you have to follow those order of operations. So if you remember PEMDAS, parentheses, exponents, multiplication, division, subtraction. Okay? So what do we have to do first in this problem? We have negative radical 10 plus 4 radical 2 times radical 6, or 6 radical 5. Can we add, or do we need to multiply first? Yeah, you have to multiply. Remember, think PEMDAS, you have to multiply first. So we multiply here. We're going to keep this radical, this 5 radical 10. When we multiply, again, multiply the numbers out in front. 4 times 6 is what? 24. Good. Then multiply the numbers underneath the radical. 2 times 5 is 10. After we multiply, do we have like radicals that we can combine? Now, when we combine those, negative radical 5 plus 20, negative 5 radical 10 plus 24 radical 10 gives us what? Think what's negative 5 plus 24? 19. Tack on that radical 10. It does not change when you add. It only changes when you multiply or divide. Questions over that? If we take a look at B, what do we have to do first here? We have to multiply. We have parentheses. So do that first. Inside my parentheses, it's telling me to multiply. So everything else is staying how it is. Plus, what do we get when we multiply radical 2 times radical 3? Radical 6. Yeah, you just multiply the numbers. 2 times 3 is 6. And then that radical 13 stays how it is. Now we're just left with addition and subtraction. That's what we're doing. Okay. So we combine our like terms. Here's a 13. Here's a radical 13. We combine 19 and radical 13. What do we get? Think what's 19 plus 1? 20. Stack on the radical 13. These both have radical 6s again. Think of it as a 1 out in front. What do we get when we combine negative 11 and 1? Negative 10. And then tack on their radical 6. Can we do anything else with this problem? Nope. So we are done. questions? Yeah, two more? Two more. We take a look at C. Whenever we have a fraction, you have to take care of everything in the top and the bottom of the fraction. So there's stuff going on in the top, clean that up first. If there's stuff going on in the denominator, clean that up, and then worry about dividing and combining like terms. So I notice in the top of my fraction, I need to multiply. So I have to take care of that before I can do anything else. Okay? When I multiply, what is 6 times 3? 18. Radical, what is 14 times 2? 28. All over negative 9, radical 7. And we have plus radical 8 and minus radical 2. Okay, so let's clean this up some more. Thank you. So we have to divide here, again, before we can do anything else. We got to get rid of that fraction. So when we divide, again, divide the numbers together. What's 18 divided by negative 9? And then divide your radicals. What is 28 divided by 7? 4. And then we have plus radical 8 minus radical 2. Thank you. Okay. We don't have any like terms, but when that happens, look and see if you can simplify your radicals. Can we simplify radical 4? Yeah, what do we know about radical 4? It's a perfect square. So that becomes negative 2 times, because again, we're multiplying 2 and the radical together. So that's helpful, right, as parentheses. What's the square root of 4? 2. Plus, can we simplify radical 8? Yeah. What's the largest perfect square that can go into 8? 4. How many times? 2. I'm going to move this down to more room. Just doesn't want to move cohesively. Okay. So the square root of 4 is 2. Can't take the square root of 2, so we leave it. There's nothing we can do with negative radical 2, so we just drop it down. Clean this up here. What's negative 2 times 2? Negative 4. We have like terms there. What do we get when we do 2 radical 2 minus radical 2? What do we get? I think there's positive 1. So you can write the 1. You don't have to write the 1. If it's helpful, write the 1. That becomes 1 radical 2. Questions over that? One more. You get time to practice. We take a look at D. Do we have any like terms we can combine? Is there anything we can do? No. So when this happens, what do we need to look at? You can try to what? Simplify. Very good. We need to simplify. So let's look at 24. Is there a perfect square that can go into 24? There is. What's the largest that can go into 24? 12 not perfect square. 4. 4. How many times? 6. What's the square root of 4? 2. Can't take the square root of 6, so bring it down. Can we do anything with 6 radical 3? Nope. So I'm just going to drop it straight down. That's going to say plus 6 radical 3. Can't simplify that any further. Let's take a look at 27. What's the largest perfect square that can go into 27? And it can go in 3 times. What's the square root of 9? Oh, that's a minus sign. Make sure there's a minus sign here. Bring that minus sign down. Okay. Square root of 9 is 3. Can't take the square root of 3, so we tack it on. Now, do we have like terms we can combine? Yeah. Combine our like terms. Can't do anything with 2 radical 6, so we leave it. What do we get when we do 6 radical 3 minus 3 radical 3? 3 radical 3. Nothing else to combine, so we are done. Okay. The rest of the time is yours. You have try those on your own. There's solutions on the bottom that you can